Hi everyone. Today we are going to discuss the ninth class physics, the problems related to 1D motion. That's very clear. So let's have a look. Yes, you would like to go for this one. Yes, 1D motion and related problems. Okay, it's very clear. Yeah. Yes, meanwhile, we are going to discuss about that 1D motion. So, the motion of your body has been restricted to move along one dimension. It's very clear. So, if you are going to take that horizontal or vertical or any whatever along one direction, if you are going to take x axis, y axis, z axis, if you are going to move in the lift, just you are going to move in upward, downward direction, whatever it may be, or you are walking on the plain ground, it's okay. It is all about 1D motion. All right. Now, if you are going to take that vertical displacement, horizontal displacement, you have to confirm, right? It's very clear. You would like to go for that, yeah. Along one dimension, along 1D, just we have to take that. So, we would like to go for this one. This is very clear. The motion of your body which is going to be restricted along one direction. So, you can take that this is the origin. You have to take that. Yes, you would like to go for this one. So, that is going to be x, yeah, x1, x2, x3. So, all these are going to be the distances covered by the body. In the time, this is going to be t1, it's going to be t2 and t3. It's very clear. So, as the time increases, distance covered by the body which is going to be increases. Distance never be negative. Even though if you are going to take the displacement due to the change in the direction, does it may have that less value. Okay, the distance never be 0. It's very clear. Okay, if you are going to get this one, so vertical displacement, you have to get that vertical displacement. Yes, you have to confirm this one. Whenever you are projecting, whenever you are taking the clay, one case, let us see the possibility. Yeah, already we have discussed that it's moving horizontal, it's going to be horizontal direction. It's very clear. So, you can write x is equal to at plus bt square, like that. We are going to write down like a function. Yes, here also vertical displacement is going to be taken. Just you are supposed to identify this one object is there. Yes, it's going to be in the direction. Does it covers the height h? If it has been thrown up, you have to take that boundary conditions. Initially it has been started with the particular velocity, okay. All right, it's going to be taken that initial velocity. Yes, you can take that final velocity. Very clear. You are going to identify these 2 points which are very important. If your body which is thrown up in a perpendicular direction, let us assume it will covers the vertical displacement. Simply we would like to go for this one h. Sometimes we can confirm it is going to be the maximum height. If the final velocity is going to be 0, yes, if the final velocity is going to be 0 at that point, then the vertical displacement is nothing but maximum height. All right. So it's very clear, we would like to go for this one. Vertical displacement, it's going to be H maximum, all right. Yes, it is very clear. We would like to confirm this one. In case of a vertical displacement, the initial point and the final point, it's going to be 0. At the final point, if the velocity of the body which is going to be projected along 90 degrees is going to be 0, then only the distance covered or the displacement, vertical displacement, it's known as maximum height reached by a body, all right. It's very clear. Now you can take that, yeah, it's very clear that generally we are representing the final velocity v is equal to 0, all right. Yes, you can take that, this is very clear. You will get the equations, it's very, very important for you, the equations of motion, all right. You know very well about that, v square minus u square is equal to 2a, yes, this is the one equation which is, this is the one we can correlate that for the motion of a body along one direction. Yeah, we would like to get that uniform motion to have that. All right, it's very clear. Here we would like to go for that A is equal to G. Yes, you can take that. Yeah, it's going to be minus G. Yeah, it's going to be plus G. It's very clear. In case of a projected body, you have to take that negative sign, which is going to be the against to the acceleration due to gravity. It's very clear. Yes, okay, you can take that. So this is the equation number 1. It's going to be equation 2, let's assume. You would like to represent this one if S is equal to H maximum. Yeah, you have to confirm this one. It's very clear. You would like to go for this one. All right. Please take that. If V is equal to 0, then S is equal to H maximum. This is very, very important. All of you please have a look into that matter. Yeah. The final velocity is going to be 0. Then the vertical displacement or the distance covered by the body, the distance covered along that y-axis, it's going to be the maximum height. All right, it's very clear. You can have the substitution and solve the problem. It's very clear. Now, if you are going to have the substitution, let's see. All right. Okay. You are going to take that within this equation, you have to substitute. This is very, very important, all of you. You have to get this one. Yes, everybody has to see, this is the very important point. We would like to go for that expression to get the maximum height. It's very clear. All right. So you can substitute 0 square is equal to u square is equal to 2 into minus g into h maximum. It's very clear. All right. Okay, it's very easy to get the expression. After that, you are going to get this one. H maximum is equal to u square by 2g. It's very clear. Yes. If a body has been projected with an initial velocity, after reaching the final point, after reaching the top, how you will decide that which is going to be the maximum height? At where the final velocity is going to be 0, that is going to be maximum height or the maximum distance covered by the maximum vertical distance covered by the body. It's very clear. This is the one we would like to go for this one. All right. So we would like to go for that h maximum is equal to u square by 2g. It's very clear. You can solve the problem. What we have taken, this is going to be the 0 and we have to taken that sign, g is equal to minus. It's very clear. Okay, let's see that the problems related to the maximum height. We would like to go for that. Yes, you may have that. Yeah, it's very clear. We would like to go for this one. It has been projected here like that. So, it's going to be 0. At this point V is equal to 0, then H is equal to H maximum. It's very clear and simple, you can confirm. Okay. All right. Let's go for that. Let's have one animation to have the better understanding. It's going to be there now. You have to confirm. It's very clear. Yes, if you are going to identify that the maximum height reached by a body has been defined, it's a final velocity where the final velocity of the body is going to be 0. In its path at a particular point, its final velocity is going to be 0. Then it is known as maximum height reached by a body. It is the case. All right, it's very, very clear. You would like to go for this one. This is easy for you to have the better understanding. All right. So you can confirm this is the case. Yeah, final velocity. Just you have to take this one. It's very clear. You can take that. Final velocity is going to be 0. Is 0. All right. Okay. Yes. All right. Then H is equal to maximum height. That is going to be H maximum. Yes, if you have taken that, it has been projected in a particular direction. Yes, you can take that. If you have been projected a one body, all right, at 90 degrees, it will reach us. It is projected other than 90. It's very clear. Suppose if you have been projected a one ball in 90 degrees. Okay, so you will project the ball and it will reach the maximum height. How you will define at maximum height? The final velocity is going to be 0. It's very clear. So we are having that expression that's going to be that H maximum is equal to, you can define that U is, you can define that U initial, yeah, it's going to be initial velocity. All right. Okay, it's very clear. So you have that final velocity V is equal to 0. Therefore, H maximum is equal to, yeah, H maximum is equal to U square by 2G. It's very clear. We will go for this one. Yes, you can take that. One important relation, maximum height, if you are going to take that H maximum 1 by, you will take that, it's very clear. We would like to go for that, yes, H1 by H2. Another body which is going to be projected at an angle, this is another body, this is going to be taken, this is also identified H2, this is H1. So how you will frame the relation among these parameters? You can take it. Yeah, H1 is the maximum height reached by the body in case of first one. Okay, after some time, if we have been projected another body, yes, with an initial velocity that is going to be U1, this is going to be U2. Then this is very clear, you would like to get this one, right? H1 by H2, it's going to be equal to, yes, yeah, you have to take that U1 square by U2 square. It's very clear, you will get this one. Yes, if you are going to get this one, G is equal to constant, acceleration due to gravity, it's going to be constant, no doubt at all. We would like to go for these problems. Yes, the concept is very clear for you, you can get that. It has been projected other than 90. Okay, if you project at 90 degrees, what happened? It will reach the same path. All right, if you have been projected in another direction, it will reach another path. Okay, during the journey it's going to be having that the acceleration due to gravity, it has been acted upon the ball, you have to get this one, right. So, you have to take that A is going to be the negative, it is very clear. At the same time you can get that additional information regarding to this topic. So, the time taken by the body to reach the maximum height, that is going to be the time of ascent. You have to learn all these topics. The time taken by the body to reach the maximum height is known as time of ascent. Very clear? Okay, all right. The time taken by the body to reach the ground. Yes? Yeah, you have to confirm that it is going to reach the ground. All right. So, the time taken by the body to reach the ground during its journey, it is going to be known as time of descent, time of ascent, time of descent. You have to confirm that. You should get that time of ascent plus time of descent, they are going to be the time of flight. You have to get that additional information. You will get that time of ascent. Just you have to get this time of ascent. How you will find out the time of ascent? Easily you can find out that. That is going to be very clear. Yeah, you know V is equal to U plus AT, alright. So, here at H maximum V is equal to 0, alright. You have to learn this one. 0 is equal to U plus of minus G into T, yes, T ascent. Yes, you have to write down like that TA, you have to confirm this one is going to be TA, alright. So, you can take that U is equal to GTA. So, TA is equal to U by G, alright. Have you obtained that expression? Alright. It is very clear, you are going to have that time of ascent. Yes, easily you will understand. Please get this one. All of you have to identify that everything is clear in this picture. As initially it has been projected with an initial velocity, it has been reached the maximum height, it was defined where its final velocity is going to be 0, that is the vertical. At that point you have to consider it has been reached the maximum height, alright, it is very clear. So, from the ground to the, yeah, you have to confirm that vertical displacement, it is going to be maximum height. You have been obtained that expression, that is H maximum is equal to U square by 2G, it is very clear. So, yes, everybody has to identify this. Okay. Now, you are going to get this time of ascent. How you will get that? Time taken by the projected body to reach the maximum height, that is going to be the time of ascent. Easily you will estimate the time of descent, time taken by the body to reach the ground from its maximum height, alright. Okay? Yes. Okay, it is clear. We are going to get this all, we are going to have the relations to get that. This is also very important to solve the problems, alright. And this is also useful for the problem solution. Okay, let us have the problem. Okay. Yes, you have to study this one. A stone thrown vertically upwards with a speed of 5 meters per second, alright. It is very clear, everybody has to find this one. A stone thrown vertically upwards with a speed of 5 meters per second, alright, they have given attains height, attains a height h1, okay, alright. Another stone thrown upwards from the same point, it is very clear what we have discussed in earlier, yeah. Just now we are having that concept, very clear, right. Another stone thrown upwards from the same point with a speed of 10 meters per second, it is very clear, attains a height of h2, right, very clear. The correct relation between H1 and H2. It's very clear. We would like to go for this one. Yes, you have to check it. H2 is equal to 4H1 or H2 is equal to 3H1. You are going to identify this one. All right. Okay, let's go for the problem solvation. We have to take that. Yeah, we can get this one. Oh, first stone, yeah, you have to get that. You can take the two cases. Yes, this is going to be case 1. Yes, a stone which has been projected, yes, thrown vertically upwards. Yes. Yes. Yeah, it's very clear. We would like to go for this one. Yes. Easily you can take that. It's very clear. It's very clear. This is going to be the H1. All right, it is going to be reached. Yes. You have to take this one. Yes, thrown vertically upwards. Okay, if it has been thrown in this direction also, it's very clear. Other than 90, we have to take that. Okay, H1. What about that initial velocity or speed? Just you have to take that. Yeah, it's going to be 5 meter per second. It's very clear. Okay, all right. You have to take that case 2. Case 2. Yes, another stone. Yes, it has been reached that maximum height. It's very clear. We will confirm that. Yes, which has been projected at 10 meter per second. It's very clear. We would like to go for this one. This is going to be the H2. Yes, maximum height reached. We may call it as the maximum height reached by a body, by the second stone. Maximum height reached by the first stone. It's going to be the H1. It is a H2. It's very clear. Okay, all right. You have to confirm this one. This is very clear. So in this case, you will get that H1 is equal to, yes, its final velocity is going to be 0. Here also its final velocity is going to be 0. It's very clear. Now if you are applying that formula, you can easily solve the problem. Let's have a look. That's going to be from the equation, basic equation, v square minus u square is equal to 2as. All right, it is very clear. Now you will get that v is equal to 0, a is equal to minus g, s is equal to h1. All right, everyone has to identify this one. All right, please, you should have the substitution. You should get that observation and get the appropriate substitutions. All right. Okay, it's very clear. We would like to go for this one. These are all substituted. Therefore, 0 square and u is equal to, you know very well about that, u is equal to 5 meter per second. What we are having that, it's very clear. So, 0 square minus, let's go for this one. All right. Yes. Yes, you can take that u is equal to 5 meter per second. All right. These are all the substitutions and get the calculation. It's better. Therefore, you have to get this calculation. That is 0 square minus 5 meter per second whole square is equal to 2 into, what about that, minus g into h1. It's very clear. So you can find out this h1 is equal to, yeah, you have to take this one, u square, that is going to be identified, very clear, that is 5 square meter square per second square by by 2g. 2g. It's very clear. We would like to go for this one. Right. Okay. Just ignore about that units. We are going to get. This is very clear. So similarly, you will get this H2. H2 is equal to, what about that? 10 square by 2g. It's very clear. You would like to go for this one. Yes, better to have that. Yes. Therefore, H2 is equal to 100 by 2g. All right. It's very clear. Here, H1 is equal to 25 by 2g. It's very clear. If you want to frame the relation, that is H2 is equal to 100 by 2g, you can write it as 1 by 2g into, yes, you have to take that 4 into 25. Yes, you can write. It's very clear. You can take that, 4 into 25 by 2g. All right. So you can substitute, that is 4h1. All right. H2 is equal to 4h1. It's very clear. So this is very easy for you to have the better understanding. Okay. Finally, what we are having, just you have to take that, which is correct. First one is the correct answer. Have the look. Everybody has to look into that matter. Let's go for that. Yes, you are all going to know about this one. Yes, you can take that H1, H2 and 2 cases. Okay, you have taken. That is very clear. So finally, what we have obtained, H2 is equal to 4H1. It's very clear. All right, let's go for another problem. Yes, it's very clear. A particle is thrown vertically upwards. Its velocity, velocity at half of the height, maximum height, you have to confirm. It has been thrown, right? You have to take that. You have to take that H maximum. Okay, all right, it's the case. Maximum height, you have to confirm. Right, if a particle is thrown vertically upwards with a velocity upwards, okay, it's very clear. What we will confirm, V is equal to 0. Final velocity is going to be 0. It's very clear. It's going to be maximum height. All right, what they have given, it's velocity at half of the maximum height. Very clear. This is going to be that H maximum by 2. That's going to be clear. Yes, what is the velocity? Its velocity is going to, yes, it has been projected in this. Yeah, you have to take this one. Very clear. What about that? Here, V, what about that 10 meter per second? Yes, 10 meter per second. It has been reached the half of the maximum height. Very clear. Okay, all right. Then you have to find out that maximum height. You have to find out that maximum height is going to be the question mark. Yes, what they have given, just you have to see. This is very clear. Yes, it's very clear. You would like to go for this. Very clear. You have to take that. It has been projected. This is going to be 10 meter per second. All right, it is the 10 meter at half of the maximum height. Okay, you know very well about that. This is going to be 0 if it has been reached that maximum height is equal to 0. It's very clear. You would like to get this one. Yes, you have to find out that this point is going to be h maximum by 2, h maximum by 2, all right, it's very clear. Okay, what you have to find out? You have to find out that maximum height attained by that body. Very simple. If you are going to know that initial velocity, easily you will find out that maximum height reached by the body. Yes, it's very clear. How you will confirm it? At maximum height, its final velocity is going to be 0. If you know the initial velocity, you can easily solve this problem. Right. Here, what we would like to get this one, a is equal to minus g. All right, it's very clear. So you can apply that v square minus u square is equal to 2as. All right, it's very clear. This is the basic equation, we would like to use it. Right. Okay. Yes. It's going to be taken. All right. So this is you can divide it. Yeah. This is the one case. This is the second case. All right. Yes. You can take that. Yes. You will apply this one. Yeah. V square is equal to u square minus 2gh. All right, it's very clear. You can confirm that h is equal to h maximum. All right. So at maximum height, what happened? You have to see that. It's very clear. All right. Get this one. If it has been taken, that is, this is the first equation. Yeah, this is going to be that one equation, right? Yes. Another equation, if you are going to get this v square is equal to, yeah, very clear. You can take that 0 is equal to u square minus 2gh, let's assume. All right. This is equation number 2. All right. So 10 square is equal to u square minus 2gh by 2. All right. It's very clear. You can confirm that. At half of the maximum height. Yeah, very clear. Half of the maximum height, speed is, it's going to be, yeah, is equal to, velocity is equal to, v is equal to 10 meter per second. All right. You can take that 10 square is equal to u square minus 2g into h by 2. All right, it's very clear. Therefore, 100 is equal to u square minus gh. This is equation number 3. All right, you are getting this one. You can go for these two equations, you can solve the problem. It's very clear. Right. This is at maximum height. This is at half of the maximum height. Are you getting this point? You have to confirm. It's very clear. Okay. Yes. So, we would like to go for that problem solvation. Already you can write this one. It's very clear. 0 is equal to u square minus 2gh. You can get that subtraction. Yes, it's very clear. yes, 100 is equal to 0 plus GH. All right. Now you would like to go for that here G. Your aim is going to find out that H. It's very clear. So we are going to subtract this one. Yeah, it has been identified that. Very clear what we are going to get this. So from this one, what we have written. All right, you have written and you have been subtracted this one. It's very clear. You would like to go for this one. Yeah, finally what we have obtained, that is GH is equal to 100. H is equal to 100 by G, that is 10 by 100 by 10. You will find out this one. So you have to take G is equal to 10 meter per second square. Yes, finally H is equal to 10 only, that is 10 meter. It's very clear. Yes, have you obtained that? This is the correct answer for you. You have to get this one. Yes, we have taken final velocity is going to be that 0. It's very clear. All right. But we don't know the initial velocity. They have not given. But at the half of the maximum height, its velocity is going to be considered. That's going to be 110. You can get this equation. Yes, but you don't know initial velocity. Keep it at u square. It's very clear. At half of the maximum height, it should be taken 10 square. It's going to be 2gh by 2. Half of the height, you have to take that. This is going to be that h by 2. All right. Just you have to see this one. Everyone has to identify this. Please go for this one. It's very clear. You would like to go. Yes, you have to see that. In what way does we have been approached that? Okay, all right. In this way we can solve the problems, what they have given the conditions. All right, let's go for another one. It's very clear we would like to go for this. Yeah, we are going to get that vertical distance. Distance covered at different time intervals. It's very clear. Have you seen this one? It's going to be taken that T1 within the time period of, within the time it has been reached that position. Just you have to confirm. Yes, we would like to go for this one. At different time intervals, it has been covered that different distances. All right, it's very clear. It's going to be, all right, just get this one. Very easily you will find out that at T1, all right. Yeah, you have to take this one. It's very clear. No doubt at all. Right. Very clear. Very clear. Just have you seen this one? Very clear. It's going to be covered. All right. All right. Okay, you have to take this one. This is going to be time T1, T2, T3. It's very clear. In different time intervals, it has been covered the distance. You have to confirm. All right. So let us assume this is going to be, yeah, this is going to be S1. Let's assume. Okay, in second, it's going to be another one. You have to take this one. Yes, in 2 seconds it's going to be very clear. All right. If you are going to take that in another time, yes, you have to take that. Yes, what we are going to get this one? This is, you have to take this in 3 seconds. In, yeah, you can take that T1 is equal to 1, T2 is equal to 2, T3 is equal to 3 in 3 seconds. It has been covered. All right, it's very easy for you. This is in, you have to take that same color, it's better for you. This is in t is in 3 seconds. Very clear. You can easily find out that by using the formula, that is in 2 seconds. This is in 1 second, it's very clear. So, by using the formula S is equal to ut plus half at square, it has been started from the rest, you have to confirm u is equal to 0. In this fashion, we will solve the problems, very clear. So, the distance covered by that body in 3rd second. Right, easily you will find out that that's going to be S3 minus S2, S2 minus S1. All these are identified, okay students. In the coming classes also we would like to deal the problems based on this concept. Thank you very much, have a nice day.